Hello, welcome to episode 6 of my Mathematical Tricks and Nonsense series. In our last episode, we covered the golden interval and how to calculate intervals based on equal temperament. Now we're here at the piano where we are in equal temperament, so we're just going to go to the closest interval. So we're going to cover the Fibonacci sequence today and to see what that sounds like in music. Now, as you can see, the Fibonacci sequence is just a sequence of numbers 1, 1, 2, 3. I'm not going to go over that. I'm sure you know that. That converges to the golden ratio if you take the each number and divide it by the previous. So 1 over 1 is 1, 2 over 1 is 2, 3 over 2 is 1.5, 5 over 3 is 1.667, and so on and so forth. And they get closer and closer to phi, which is 1.618. And it continues on. It's an irrational number that continues on forever. But basically, one thing to note is this is too low, this is too high, low, high, low, high. See? And the so basically, if you look at the difference each number is with the phi, you can see it starts negative, goes positive, negative, positive, negative, positive, all the way to 007, which is where golden eye comes from. Nah, just kidding, that's nonsense. Anyway, so now we're going to see what the Fibonacci sequence sounds like. So just starting on like a C. Then you go to 1 over 1 is 1, so it's the same note. And then 2 over 1 is just the octave. And 3 halves over is just going to be the perfect fifth. And then the major fifth. And then the 8 over 5. And then it's, you know, starts to get to change from there. So as you can see, it's very harmonious, which isn't surprising because just the harmonic series itself is very harmonious. But that's in frequencies, right? Starting with the base frequency and then following the Fibonacci sequence from there, right? So if we were doing it from lengths, you know, we'd start with a wavelength and then add, you know, to so we would have to go the other way down. So let's start here. And then we want to add that wavelength to itself. We would get twice that wavelength, which would be an octave down. And then we would add those two wavelengths, we'd get this wavelength. And then if we added these two wavelengths, we'd get this wavelength. These two. See, when I hear that, it doesn't sound very harmonious just to play the chord, right? Let's see. I mean, it's not that bad, but it's definitely like a minor chord. Plus, it's kind of inverted so that the root is not in the bass. You know, like that would be the same chord, but you know. But it's like, but I think what I like to hear is like a sequence. So to me, it sounds like it's almost burrowing down. You know, if it's like you can like drive it down there, and then you could come back up with the same, you know, Fibonacci sequence going up. Anyway, hope that helps you.